Hello, dear students. We will continue our revision in physics. First, the first question come from our student with how to find the experiment to prove that. Experiment to prove that all gases can be compressed. This question from our student Bishoy, all gases can be compressed, or compressibility of gas, explained by experiment. We get two flasks. The first flask filled with hydrogen chloride, and we put another flask filled with ammonia gas. We find that ammonia gas will diffuse downward in spite of it has low density, and HCl, hydrogen chloride, diffuses upward in spite of it has high density. That's due to it contains large intermolecular space. We find that between them fumes, which is called NH4Cl, which is called ammonium chloride. Ammonium chloride. So this experiment verify that all gases has large intermolecular spaces and gas can be compressed by using two flasks, one of them filled with hydrogen chloride and the other filled with ammonia gas. Invert the jar which is filled with ammonia gas over the jar which is filled with hydrogen chloride. We find that fumes of NH4Cl, that's due to the diffusion of NH3 and HCl, that's due to the large intermolecular space of the molecules and the distance between them, so all gas can be compressed. Another question about the slope. If we have graphical representation, you have to think the graphical representation, how to think in this. We have two quantities, pressure and depth. We have to find the relation between the pressure and depth. Pressure and depth. This is a straight line. The rule which is related by depth and pressure, which is P equals PA plus rho GH. This value is called atmospheric pressure, which is equal to atmospheric pressure. So the slope equal rho G. The second slope like this, P and H. In this case, the liquid not exposed to air. So slope equals rho G. Third slope between angle of deviation and angle of incidence in case of minimum deviation. We know that in case of minimum deviation, the angle of incidence is equal to angle of emergence. And this case, this is at this point is called at minimum deviation, so the angle of incidence is equal to angle of deviation. And the rule in this case, N equals sine alpha plus A over 2 over sine A over 2. Another slope between current intensity and time, AC current and time. In this case, current intensity and the time. If the graph like this, it gives a curve which is half cycle. At this point, maximum current. maximum current, and this distance on x-axis time of half cycle. So we can find the time of cycle, which is called periodic time, and we can find the frequency. The maximum current, we can find also effective value of AC current. I effective equals I maximum times 0.707. This is the relation between effective value of AC current and the maximum current, which is the rule, which is I effective equal I maximum times 0.707. Another slope between magnetic flux and time. This will be straight line like this, and if the line is parallel to the x-axis, EMF equal 0, because no change in magnetic flux density. So the slope equal delta phi over delta t in the part of x, y only. So this is the relation between magnetic flux and time. We have another slope. It is very important to deal with the slope. Point force, FB, and volume. The line will be straight. We must think about this. We find the rule which is related between the point force and the volume. We know that FB equals rho VG. Then FB divided V equal rho G. Then the slope equal rho G. And another slope between FB point force and also rho. The slope will be equal FB over rho, which is equal V times G. We know that we have two cases in Archimedes. When a body wholly immersed, then FB equals rho VG, rho liquid, and the volume of the body and the gravity. Wholly immersed in this case, immersed, or FB equal weight of the body in air minus weight in liquid, or FB equal decrease in weight. Decrease in weight. In case of floating, FB equal rho liquid V immersed G, which is equal to rho solid VG, which is equal to mg. In case of floating, the point force equal rho liquid times the volume immersed times gravity, which is equal to the weight of floating body, which is equal to rho solid times V times G. So the point force does not affect. In case of floating, FB is constant in two cases. When the ship transfers from sea to river or from river to sea, the point force are equal. So the ratio between them is equal to 1. But the difference between them is the volume immersed. If the density of the liquid increases, the volume of part decreases. If the density decreases, the volume of immersed part increases. So we have two cases in Archimedes, FB equal rho liquid VG, and FB weight of air minus weight of liquid, and FB equal decrease in weight. In case of floating again, FB equal rho liquid V immersed times G, which is equal to rho solid V times G, and equal mg. In problem of Archimedes, we have to think first, does the body immersed or float? If the body immersed, we use the rule of immersed. If the body float, we use the rule of floating. That's very easy. And we deal with a body at equilibrium. That means the upward force is equal to downward force. What's the meaning of that? I will explain this. We deal with a body at equilibrium or at balance. So upward force force equals downward force. Look at this figure. If we have a body wholly immersed in liquid, like this, we find that the force acting on this body is the weight to downward and FB to upward. Also, if we have a tension in a thread, we have tension. So we have three forces. FB act to upward, and tension act to upward, and the weight of the body act to downward. We deal with the body at equilibrium. So the upward force is equal to downward force. So FB plus tension is equal to weight. What is the rule of FB? A body in this case is wholly immersed. So FB is equal rho Vg, rho liquid time volume of the body time the gravity. And the tension we can find the tension also, we can find the weight. In the problem it gives you tension and the weight and to find FB, or to find tension by using weight and FB. If the tension from downward, from this, and we know that the body is stretched to downward by tension T and the weight W and FB to upward, we find that the upward force is equal to downward force. FB equals weight plus tension. We can find FB, which is equal rho Vg. Weight, it equal m times g, and tension, we can find the tension in the wire. So in Archimedes, we deal with a body at equilibrium. The upward force is equal to downward force. We have a problem about floating body. A body float on water, and raw water equal 1000, where 3/4 of its volume immersed. Find density of body. We know that a body floats. This is the word of secret, the secret words. Float. It means that FB equal rho liquid V immersed v G, or FB equal M times G, or rho solid V times G. We can write rho liquid V immersed G equal rho solid Vg. This is the case of floating. Rho liquid, which is equal to 1000, times volume immersed 3/4 V times G equal rho solid V times G. We can cancel G and V. So rho solid is equal to 750 kilogram per meter cube. This is in case of floating. So the floating body, the point force is equal to weight of displaced liquid by the immersed part. But in case of wholly immersed, the point force is equal to the weight of displaced liquid by the whole body, which is displaced the liquid. And we have another example. Mention Pascal principle. Pascal principle and its application. One of its application. Pascal principle states that when a pressure is applied to an enclosed liquid, pressure is transmitted undiminished to every part of the liquid and to the wall of the container. That means if we make a pressure on a liquid, this pressure will transfer to every part of the liquid and also to the wall of the container. From the application of hydraulic press is hydraulic brakes or hydraulic press, which is contains two pistons, one of them small piston and the other is large piston. If we make pressure on a small one, the pressure will transfer to the large one. So the ratio between the pressure acting on a small piston is equal to the pressure acting on large piston according to the Pascal principle. But the force acting on large piston is greater than the force acting on the small piston, so the ratio between them equals more than 1 if we start with the pressure acting on large piston. But if we start with the force acting on a small piston, the ratio will be smaller than 1. So mechanical advantage equal, which is the ratio between force acting on large piston to the force acting on small piston, or area of large to the area of small, or distance moved by small piston over distance moved by large piston. Mechanical advantage unitless. We use liquid because liquid are incompressible. We don't use gas because all gases are compressible, so most of the work done is consumed to get the molecules of the gas close from each other, so liquid are used in hydraulic press. And after this, mention the condition of of 1. Total reflection. Number 2, constructive interference. 3, emission of electrons by means of light. Number 4, condition of emission of X-ray. The first, mention the condition of total reflection. We know that if the ray make total reflection, the ray have angle more than critical angle. If the ray have angle less than critical angle, it will refract. Equal critical angle, it will refract with 90 degree. So 90 is greatest value of angle of refraction. But if the ray have angle more than critical angle, it will be totally reflect. And the second, the condition of constructive interference. In case of constructive interference, the bus difference must equal m time lambda. If the interference between transverse wave, crest meet crest and trough meet trough. Longitudinal wave, compression meets compression and refraction meets refraction. And the third condition, emission of electron by means of light. When light falls on a surface of metal, we find that electrons are ejected from the surface of metal. This is a condition for this process. The light which is fall on the metal must have frequency greater than the critical frequency. So the light which fall on the metal must have frequency greater than the critical frequency in order to make the metal emit electrons. Also, the condition of emission X-rays, we use high potential difference and we use cathode rays. Cathode rays collides with a target. This target making from metal, and the X-rays having wavelengths. This wavelengths depend on the atomic number of the target, and if the wavelengths decreases, the atomic number of the target increases. So atomic number and the wavelength is inversely proportional to each other. This is a condition of emission of X-ray. Also, we can tell you about X-rays, the properties of X-rays. It travels in straight lines. It has great ionizing power. It diffracts through crystals because between the crystals narrow intermolecular spaces, and it will diffract is used to test for the crystals. Also, X-rays are used in imaging bones or used in medicine purposes. And after this, we have many questions. First, we start with a problem from Siham. The first, the pressure difference, needed to move gas of volume is 1.5 times 10 power 5 Newton per meter square. Find the work done. Find the work done. The pressure difference needed to move a gas of volume 20 meter cube is 1.5 times 10 power 5 Newton per meter square. Find the work done. I will tell you the problem again. The pressure difference needed to move a gas of volume 20 meter cube is 1.5 times 10 power 5. Find the work done. Work done equals pressure times delta B times V. So delta B 1.5 times 10 power 5 times 20, which is equal to 3 times 10 power 5 joule. This is the work done for a gas to be its volume 20 meter cube. And another problem, a cube float on water surface. Cube float on water surface where it's 1/4 of its volume appear. Concentrate. 1/4 is appear, so 3/4 of the volume is immersed. The mass of the cube, is 150 gram. Find wood density and volume. We know that raw water equals 1000. So a cube float, the meaning of float, it means we use the rule FB equal raw liquid V immersed G is equal to raw solid VG. We can cancel G with, and raw liquid equal 1000. Volume immersed, we know that 1/4 of the volume is appeared, so 3/4 of the volume immersed. We deal with volume immersed equals raw solid times V. We can cancel V, then raw solid equals 750 kilogram per meter cube. So we want the volume of the cube. We know that rho equals mass over volume. The mass of the cube, which is equal to 150 gram, we convert it times 10 power negative 3 to be kilogram over 750. We can cancel. We can find the density of wood by using calculator. So in this problem, we deal with a body float on the water surface. So we use the rule raw liquid V immersed G is equal to raw solid V times G. We have to concentrate and read the problem carefully. We must know the given of the problem, and you must give the relation between all the given in the problem and to find the rule which is used to solve this problem. All the problem, the missing is one thing only. You have to find it from the different quantities which are given in the problem. And let's move to another problem from Sami Hussein. What's meant by sensitivity of galvanometer? Sensitivity of galvanometer. Mathematically, sensitivity theta equals theta over I. It means scale deflection per unit current. Scale deflection per unit current. And sensitivity of a meter. Sensitivity of a meter, concentrate, equals Ig over I or Rs over Rs plus Rg. I will write it again. Sensitivity of a meter, Ig over I, which is equal to Rs over Rs plus Rg. Rs, it means shunt resistance. Rg, the resistance of the coil of galvanometer. Sensitivity unitless. So sensitivity of voltmeter, which is Vg over V, which is Rg over Rg plus Rm. The sensitivity of galvanometer, theta over I, scale deflection per unit current. Sensitivity of ammeter equals Ig over I, which is Rs over Rs plus Rg. Sensitivity of voltmeter, Vg over V, which is equal Rg over Rg plus Rm. All this can be used in solving some problem. We have another question. The atomic number of silicon, or the mass number of silicon, is 28 gram. And Avogadro number, which is denoted by Na, equal 6.02 times 10 power 23. Find number of atom in 10 gram. It is a very easy question. We know that Avogadro number is the number of atom or molecules in the atom. The number of atom in 1 mole, and Na is equal to 6.02 times 10 power 23. So mass number of silicon equal 28. So 28 gram contains 6.02 times 10 power 23. So 10 gram contains 10 times 6.02 times 10 power 23 divided 28. So the number of atom equal 10 times 6.02 times 10 power 23 divided 28. So we can find the number of atom in silicon. And the other part of this problem, if you given concentration of hole in pure crystal is 10 power 10. Then we add boron. We know that boron is trivalent. Boron, it makes hole, it means acceptor. With concentration 10 power 12. So the crystal will be B-type. Find the concentration. Of hole. We know that law of mass action, Pn equals Ni square. Ni square, which is equal to 10 power 10 all square. So P equal 10 power 12 times N, then N equal 10 power 8. This is the value of concentration. Another problem, or we can take another example, compare between P-type and N-type. Compare between P-type and N-type. B-type is a crystal of silicon or germanium doped with element of third group. Element, crystal, doped with element of third group, but this fifth group. In B-type, charge carrier is whole, and in B-type, electron. Both of them neutral, and both of them good conductor, and charge carrier whole, and the charge carrier is electron. Its potential is negative, and its potential is positive in case of this donor and this acceptor. And so this is a comparison between B-type and N-type. B-type is a crystal of silicon or germanium doped with element of third group, and it makes a hole. This hole is called acceptor. It can accept electrons. The potential of it is negative, and the charge carrier is whole, and its potential is negative, and all the crystal is neutral. In N-type, a crystal of silicon or germanium doped with element of fifth group, and charge carrier is electron, and the neutral, its potential is positive and donor. This is a comparison between B-type and N-type. We have to make to be attention for this question. And we have another problem for viscosity. Two parallel plates at distance between them is 2.5 meter, filled with oil. We have two parallel plates, between them 2.5 meter, and the two parallel plates filled with oil. Calculate the force needed. Calculate force needed to move thin plate at distance 0 point at a distance, and to move a plate is at a distance 1 meter of area, 0.75 meter square. Then find pressure given eta, coefficient of viscosity, equals 0.785 kilogram meter negative 1 second negative 1. The problem is two parallel plates as shown in the figure. This, the first plate, and the second plate. The distance between them 2.5 meter, and we have a thin plate between them. at distance 1 meter from one of them, and the other distance 1.5. And the area of this is equal to 0.75 meters square. We find the force. We want to find the force. We have two forces, F1 and F2. F1 equals eta A V over D. Over D. Then F1 equals eta 0.785 times 0.75. This is the velocity. Velocity equal 0.75 times 0.5 over distance 1, and we find F2, which is equal to 0.75875 times 0.75 times 0.5 over 1.5. We get the two forces. Then total force F equal F1 plus F2. So the pressure is equal to 0 because the coefficient, the force of viscosity is tangential force. When the force is tangential, the angle will be 0, so the pressure is equal to 0. In case of coefficient of viscosity, the force does not make pressure because the force is tangent to the surface. When the force is tangent to the surface, the pressure will be 0. Let's move to another question. We have two wires, two parallel wires as shown in the figure. The first wire carrying a current 40 ampere, and the second wire carrying a current 20 ampere. The distance between them 0.3 meter. 0.3 meter. Find the total magnetic flux density at point X, which at distance 0.2 from the first wire and 0.1 from the second wire, if the current passes in same direction and the current passing in opposite direction. First, when the current passes in same direction, B total equals B1 minus B2. B1 equal mu I1 over 2 by D1 minus mu I2 over 2 by D2. Then B total equals mu over 2 by I1 over D1 minus I2 over D2. This in case of the current passes in same direction, because the magnetic flux density, we know that we can find the direction of field by using Ampere right hand rule. We find that the flux density, the flux lines, and in this case the flux lines, if the two wires having the current in opposite direction, the flux density will be in opposite to each other, so weak field between them. So the net field will be B1 minus B2. And in second cases, if the current passes in opposite direction, B total equal B1 plus B2. Then current in opposite direction, B total equal B1 plus B2. We can find post value. This, let's move to another question. In the following, find the truth table for the following. Complete the truth table of the following as A, B, and output. The circuit is OR gate, has two input connected to NOT gate. This A and B. A 0 0, B and 1 0, and 0 1, and 1 1. We want to complete. In the first, A 0, 0 in NOT will be 1, and A 0 0 it gives 1, and 1 0 it gives 0, and 0 1 it gives 1, and 1 1 it gives 1, because OR as two key connected in parallel. So this is a truth table, and we complete it in case of NOT gate and OR gate. What is meant by each of the following? Wien's rule, Wien's law. Wien's law states that the temperature is inversely proportional to wavelength, but the temperature in Kelvin. So Wien's law states that as the temperature in Kelvin increases, the wavelength decreases. So lambda T equal constant. This is Wien's law. If we draw graphical representation between temperature and wavelengths, the relation will be inverse proportion. As the temperature increases, the wavelength decreases. This is Wien's law. We can write it lambda 1 over lambda 2 equal T2 over T1, but the temperature in Kelvin. Another question, what's meant by thermal dynamic equilibrium? Thermal dynamic equilibrium. In case of increasing the electrical conductivity for semiconductor, we know that semiconductor neither good conductor nor bad conductor. If we want to increase its electrical conductivity, how we can do that? By two methods. The first method, by rising its temperature. When we rise the temperature of semiconductor, the bond between the molecules are broken. This leads to presence of holes. These holes allow to accept or attract electron to it, and it becomes good conductor of electricity. So the first method to increase the conductivity of semiconductor by increasing its temperature. So in this case, we have two cases, breaking a bond and formation of new bond. In case of thermal dynamic equilibrium, number of broken bond, number of broken bond equal number of broken bond is equal to number of making bond. This is in case of thermal equilibrium, the number of broken bond is equal to number of making bond. And the second method to increase the electrical conductivity of semiconductor by doping. Doping, it means inserting element in crystal from third group or from fifth group, so we obtain N type or B type of semiconductor that we can increase its electrical conductivity. Let's move to another question. In electron microscope, is used to see virus of length 18 times 10 power negative 12 meter. Find the potential difference. Find potential difference needed for electron of charge 1.6 times 10 power negative 19 coulomb, and its mass 9.1 times 10 power negative 31 kilogram, and Planck constant H equals 6.6 times 10 power negative 34 joule second. I will tell you the problem again. Electron microscope is used to see virus of length 18 times 10 power negative 12 meter. This length of virus is equal to the wavelength of electron, because if you want to magnify any object, we must use a light. The wavelength must be smaller than the size of the object that we want to see it. So 18 times 10 power negative 12 is a wavelength. Find the potential difference needed for electron of a charge 1.6 times 10 power negative 19, and its mass equal 9.1 times 10 power negative 31 kilogram, and the Planck constant equal 6.6 times 10 power negative 34. First, we must find wavelength equals H over M times V. M represent mass and V represent velocity. So we must find the velocity of electron first. Then lambda equals 18 times 10 power negative 12 equal 6.6 times 10 power negative 34 over 9.1 times 10 power negative 31 times V. Then V equals the velocity of electron 4.4 times 10 power 7 meter per second. We find the velocity of electron. So we want to find the potential difference of electron. We know that EV equals half mv squared. EV, E represents the charge of electron, V potential difference, E charge and V potential difference, and we have mass of electron and velocity of electron. So we can find the potential difference of electron. Again, this problem, electron microscope is used to see virus of wavelength or of length 18 times 10 power negative 12. Find the potential difference needed for electron of a charge 1.6 times 10 power negative 19, and its mass 9.1 times 10 power negative 31 kilogram, or Planck constant 6.6 times 10 power negative 34. First, in this problem, we can find the velocity of electron. The first, we have lambda, the wavelength of electron, and Planck constant and the mass. Then we get the velocity. There is a relation between kinetic energy and the energy of cathode rays. The energy of electron or cathode rays, which is EV, equals half mv squared. We have velocity and the mass of electron, and also charge of electron. We can find the potential difference, which is equal to 4651. V equal 4651 volt. This is the potential difference of electron. This very important problem. And another problem, equal resistor. It is very simple, but is very important. Equal resistors, it means we have many resistors are equal. Each of 40 ohm, each one of 40 ohm. How many resistors? How many resistors of them should connect to carry a current 15 ampere and potential difference 120 volt. Again, the problem: equal resistors, each of 40 ohm. We have many resistors. The value of each one is 40 ohm, but we don't know the number of these resistors. How many resistors should connect to carry a current 15 ampere and a potential difference 120 volt? So the problem is how many resistors. We want the number of resistors. The first, we find the resistance, the total resistance first. R equals, from Ohm's law, R equals V over I. V equals 120 and I is equal to 15. So the total resistance will be 8 ohm. The total resistance for all resistance is equal to 8 ohm. 8 ohm is less than 40 ohm. So the resistors are connected in parallel. The resistors are connected in parallel because the equivalent resistors is smaller than the smallest one. So R equivalent equal 8 ohm. We can find the number of resistors. We can find the rule. Number of resistors equals total resistance over R equivalent. Resistance is equal to 40. R equivalent is equal to 8. Then number equal 5 resistor. Again, this problem. In case of parallel, the equivalent resistance is less than the resistance of the smallest one. So the total resistance in this problem is equal to 8 ohm. So the resistors are connected in parallel. So when we want to find the number of resistors, we make division between the resistance and R equivalent. We find the number of resistors. And also, we have another experiment. How to find, experimentally, how to find experimentally the conductivity of wire, also resistivity. Explain an experiment to find the conductivity of the wire. First, we have to think about the rule which we can use it to find the conductivity of the wire. We know that sigma equals L over RA. We have to think about, if you want sigma, we must find the length of the wire and the cross-sectional area, and then we find the resistance of this wire. Again, if you want to find the conductivity experimentally, we use an experiment to find the conductivity. We have to find the length of the wire and also the resistance, and to find the cross-sectional area. So we must write the given now. First, this is a step of the experiment. Measure length of wire. At the first, we measure the length of wire. 2, measure the radius of wire. Then find